And I would like to invite our first speaker, and you're going to have 8 minutes to take 10 minutes to talk about population dynamics and education and health, so the interaction between these three drivers. We are going to listen to Wolfgang Lutz. Wolfgang Lutz is leader of the World Population Program here at IIASA, and you are one of the leading scholars worldwide on these issues, so we are very keen to listen to you, Wolfgang. Please.
Good afternoon. As has been said, this is the session on drivers, and of course one basic driver is population. How many of us, how many people there are on the planet. And the topic of population has been mentioned in the morning several times, but typically it's framed in the context of population being a problem. At least since Malthus there was the concern, additional people brings additional problems, how can we feed these additional people, what are the impacts on environmental change. But I want to focus also on the other side. It's us, the people, who will have to come up with the solutions. We are the human resources to change our societies, the human resources for sustainable development. And we'll do so by going beyond traditional demography in terms of integrating the education and health dimension into demographic analysis. And this is also the main topic of this recently founded Wittgenstein Center for Demography and Global Human Capital, which is a collaboration between IIASA, the Austrian Academy of Sciences, and the Vienna University of Economics. Naki already showed you on a log scale the trend in world population since very early years, and as you know, for more than half of human history, or most of human history, this has been a struggle of survival for the human species as well as for individual tribes, and that's why birth rates were very high in order to compensate for very high death rates. And I'm just zooming here into the last millennium, and you see that it was really only in the late 19th century that the death rates started to fall in Europe and North America, while birth rates are still at a rather high level because there are high fertility norms embedded in our cultures. And that caused population growth first in Europe, and then after the end of World War II, death rates fell precipitously in the developing countries, while birth rates were still high, and this caused what many people call the world population explosion. So you see at the moment we are around 7 billion, and these colorful lines show you the uncertainty range for the 21st century. So we at IIASA has been developing a method of probabilistic population projections. We simply don't know for sure what will be the population size at a certain time in the future. So if anybody tells you that the population of the world in 2050 will be, and then an exact number, don't believe him. There is huge uncertainties involved, and you see here the uncertainty range. We've published this paper with the title "The End of World Population Growth" 10 years ago, which shows that there's a high probability that over the course of this century, we'll see a peaking in world population followed by a decline. But clearly this is not yet a certainty. As you see, the range goes by the end of the century of a population that is less than we have today, up to more than 12 billion. So, and this largely depends on the future of the birth rate. And the world has a very heterogeneous picture. Sub-Saharan Africa, indeed, has almost a certain doubling of population embedded in its current age structure, and as well as the high fertility rates. It could well increase by a factor of 3 or even 4. On the other hand, we have Eastern Europe, where population shrinking is a near certainty. This also has to do with already changes that happen through past low fertility to the age structure. There are fewer and fewer women coming into reproductive age. And then, of course, age structure is a big concern in Europe as well as in Japan and increasing a number of other countries, the aging of the population. So here you see a probabilistic population pyramid. You see the most uncertain area is the young people, because it's the uncertainty about future birth rates and also future migration, because migration tends to be of young people. But what may be surprising is that at the very high end, there's huge uncertainty about how many 85-year or 90-year-old people there will be in Europe by the middle of the century. And this really has to do with uncertainty about the future trend in life expectancy. This is one of the most hotly contested fields in demography. How will life expectancy continue? And here you see a picture from our former IIASA colleague, Jim Voppel, who is now at Max Planck, that actually plotting the best practice life expectancy since the middle of the 19th century. And you see the country with the highest life expectancies, it's like a straight line. And these horizontal lines that are shown that said what people at different points in time assumed to be the maximum life expectancy. And reality always surpassed these expectations. So I don't think there is any reason at the moment. We don't see any sign of a flattening of the curve. And these red lines show you the UN projections that do indeed assume that gains in life expectancy will diminish. Well, it's not only how many people survive and the head count that matters, it's also what is inside the heads that has of great importance. And the UK government has these very nice foresight studies, and one of them focused on mental capital and well-being, making the most of ourselves in the 21st century, focusing on the UK. And this really gave us inspiration to look at this at a global scale. So at IIASA, we are dealing with human capital. Some people don't like the word capital because it's too much monetary, economic. We could also say the human resource base for sustainable development. And that essentially deals with people, their education, and their health. And then when you talk about education, we have formal education that's in school and informal education that starts the first day of your life and goes on until you die. And then even with the formal education, we have to distinguish between quantity, quality, and content. And when we zoom into just the formal education and the quantity, again, we have to distinguish between the flow variable, that's schooling, that's what's going on in schooling, and that absorbs much of sort of what we talk about education and what UNESCO is doing. But here we look at the stock of human capital of the adult population, and that changes very slowly and have great momentum. Now at IIASA, we've reconstructed for all countries in the world these education pyramids. So you see here the women to the right, the men to the left, sorted by age, and then color gives you the highest educational attainment. So red means never been to school, yellow means primary education, light blue secondary, and dark blue tertiary. So Korea in 1960 was a poor developing country, and you see the entire female population above the age of 30 has never been to school. But then times changed. They invested very heavily in education. You see the better educated moving from the bottom of the pyramid up. And then when the better educated young men and women came into the main working ages, this was also the time when economic growth really took off, and Korea had this phenomenal growth. And then it goes on. Here's 2010. This is the projection to 2020. Now, Korea in 2020 is likely to have the world's best educated young female population, but what you also see, the pyramid gets very narrow at the bottom. This is because higher education of women leads to lower fertility. So there's a concern about population aging, of course, and the key question, not only for Korea, but for every country also in Europe that is aging, is whether the better education of the young people resulting in higher productivity can compensate for their smaller numbers. So this is one of the big questions out there. We have used these reconstructed by age to reassess the global pattern of how important is education for economic growth. And you may know that economists have long expected this because theory tells you, and at the individual level, there's good evidence that more education gives you a higher income. But at the aggregate level of time series of countries, it couldn't be shown because the economists were using just the mean years of schooling of the entire adult population, which is sort of averaging out, as you see in Korea, the uneducated elderly with the more educated young. Now, if you differentiate by age, it comes out beautifully consistent, positive, and significant coefficients for education. And we can also show, because we have the distribution, that it is primarily universal primary and secondary education that makes the difference, rather than only focusing on elitist tertiary education while leaving behind segments of the population uneducated. And here you see China over time. You see in 1970 they had about a third uneducated, a third with primary, a third with secondary. And I claim that really the main reason for the fundamental, this phenomenal economic growth in China is due to the rapid expansion of the more educated labor force, of course together with the right economic policies. But there's also an important feedback from education back to population growth. Last year we did a review article that tried to put this into alternative scenarios. So since universally women with higher education have lower fertility, Now we assume two scenarios that have identical education-specific fertility assumptions, but make different education assumptions, and we see a difference of more than 1 billion people in the world population already by 2050. So the most pessimistic is you build no new schools. It's the constant enrollment numbers. It's unrealistically pessimistic, but it's sort of a benchmark. And under this assumption, the world population will increase to 10 billion people by the middle of the century. The most optimistic, called the FT fast track scenario, essentially assumes that all the countries could do starting tomorrow what Korea had done. And then you see this rapid expansion of the blue area, the better educated, and world population in 2050 would be less than 9 billion, so more than 1 billion difference. But education matters for so many other things. Let's look here, since we're talking about climate change. It reduces vulnerability to natural disasters and enhances adaptive capacity. We see here the number of victims, deaths to natural disasters by female education. You see a very strong relationship, and we did a special study on the three Caribbean countries, Haiti having the lowest education, and always when the same hurricane goes over the Caribbean, killing thousands of people in Haiti, killing a few people in the Dominican Republic, and usually just a few injured in Cuba. Well, the Cubans, they are much poorer than the Dominican Republic, but they know what to do and they're better prepared. Well, this all is the background for a major new effort we are doing at IIASA in the context of the new scenario building of the IPCC and Integrated Assessment Modeling Community, on trying to define new scenarios that run under the name SSP, Shared Socioeconomic Pathways, that combine the socioeconomic challenges for adaptation in one dimension against the socioeconomic challenges for mitigation. So these education-specific projections have been at the basis. We have these 5 SSP here, the example of India, produced at IIASA. Our former IIASA colleague, Brian O'Neill, who is now at NCAR, is adding on the urbanization component, and then OECD, IIASA, and PIC are translating this into alternative GDP scenarios that are fully consistent with our education assumptions. Well, in conclusion, I want to come back from this very aggregate global picture to something that is also relevant for all of us. What are the individual level returns? And here we've done an interesting study at the Wittgenstein Center about longevity of academy members as compared to the entire population. So here we look at Austria. What you see is the remaining life expectancy at the age of 60. And you see in the total population has hardly changed from the late 19th to the mid-20th century. And here you have the academicians. They haven't really done any better. They didn't live much longer than the general population. Infectious diseases killed both of them. Then, for the second half of the century, after 1970, we have a significant increase for the total population. If you look at people with university education, they are doing better, it's about 3 years more of life expectancy. But look at the academics, they are doing quite a bit better. Actually, this has really opened up. Now academicians live more than 5 years longer than the average population. And of course, we had discussions, what is the reason of this? And it's unlikely to be privileged health, access to health services. It's unlikely to be selectivity. The most plausible explanation is that academicians just don't stop thinking and don't stop using their brains and working actively. So this is a good method. Let me just come to conclusion with making reference to the morning when there was mentioned again and again that we are in need of a new narrative. Well, here we have a narrative. Let's educate everybody, at least to complete a secondary education, and just use our brains as hard as we can and as long as we can. This will be the best for our planet. It will help to bring down world population. It will enhance our adaptive capacity to unavoidable climate change. It will be the best for our development in the countries, and for ourselves it will help us live longer and even more happily that we could also. Thank you very much.